Hello students, welcome to the statistics class. I am S. Nirmala, Assistant Professor of Statistics. Today's my topic is curve fitting 2, class 2. In the previous class, I have been discussing about principle of least square and how the Lagrange has stated the principle of least square, and we have used the principle of least squares in finding the best fit for linear equations like y is equals to a plus bx, which is equation of straight line, and then for the equation of second degree parabola y is equals to a plus bx plus cx square. So those two linear equations, by applying Lagrange's statement to them, we have solved those two linear equations and got the best fit for the given values. Now today we continue the class by seeing how to apply principle of least squares to the non-linear equations. So in that, first we will see the exponential curve of type. There are two types of exponential curves for which we will fit the principle of least squares. Now how do we fit principle of least squares to the non-linear equations? We will see in the today's class. And this class is for semester 3 students. Fitting of exponential curves. So the first one is of type y is equals to ae power bx. Y power bx. This is equation 1. Equation 1 is a non-linear equation. So this is non-linear equation. So we take log on both sides. So what do we get? Log y is equals to log of ae power bx. So this is log of y is equals to log a plus log of e power bx. Now, log y equals to log a plus bx log e. Here. Since log e to the base e would be equals to 1, therefore this equation will become log y equals to log a plus bx. Now, put log y equals to u, log a is equals to capital A, then equation 1 becomes what it becomes? U is equals to A plus Bx. We have started with a non-linear equation y is equals to ae power bx. Because it is a non-linear equation, we have taken log on both sides. So we got log y is equals to log of ae power bx. So that is nothing but log of a plus log of e to the power of bx. And we know log e to the base e is equals to 1. Therefore, log y is equals to log a plus bx log e. So log a is 1. The equation has reduced to log y is equals to log a plus bx. Now by putting log y equals to u, log a equals to a, the equation 1 will reduce to u equals to a plus bx, which is a linear equation. In terms of capital A and small b. So we have reduced a non-linear equation into a linear equation. That is, if a non-linear equation, exponential curves are non-linear. So the non-linear equation we have converted into linear equation in terms of u and x. Here we have got y and x non-linear equation. We have taken the log on both sides and then reduced it into a linear equation in terms of u and x, and in terms of u and x. Now, next thing is, if this has become a linear equation, now we have to apply the Lagrange's least square principle. Lagrange's principle, here we can apply least square principle. If you have an equation u is equals to a plus bx. Now we have to write if we apply Lagrange's equation and do the partial differentiation, first we have to find out error. Error is equals to sum of squares of this. So ui minus a plus bx whole square, and then we have to differentiate with respect to dou e by dou a and dou e by dou b equals to 0. Then you get two normal equations. What are the normal equations? Let us see. By not solving all those things, how do we get the by applying principle of least squares, we have to minimize the given form. So I is equals to 1 to n ui minus a plus bx whole square minimum. And then dou e by dou a equals to, we have to take the partial differentiation. Dou e by dou a, dou e by dou b equals to 0. Now, dou e ui minus a plus bxi whole square divided by dou a will be equals to 0. So how it will be? You all have to summation ui minus a plus bxi 2 into minus 1 equals to 0. So this will be summation over I ui equals to na plus b summation over I xi. This is your equation number 3. And the same way dou E by dou P equals to 0, that is equals to summation over I ui minus a plus b xi whole square. So that will be equals to summation over ui minus a minus b xi into minus xi. That will be equal to summation ui xi that over I a summation xi plus b summation xi square. This is equation number 4. Equation 3 and 4 are called as known as normal equations and solving these two normal equations we are going to get solving 3 and 4 we get the values as A is equals to as A and B, but A is equals to log A implies small a is equals to anti-log of capital A. Now we got A value, we got B value. Substitute this A value and B value in equation 1. We are going to get the best fit for the given data. A e power bx. If a non-linear equation is given, we have to convert that non-linear equation into equation. In this case, we have multiplied both the sides of the non-linear equation with log and made it into a linear equations in terms of u and x. We have taken up our non-linear equation in y and x, but after converting it by multiplying both sides with log, we have converted our given non-linear equation into linear equations in terms of u and x. Then the linear equation is in the form of straight lines, and we know by applying principle of least squares, for the straight line, we are going to get two normal equations, and we got those two normal equations, but in terms of u's and x. After solving these two normal equations, we got the values capital A and B. But what was our capital A? Capital A was log of small a. Now we want small a values. So we take anti-log of capital A and we get the small a value. This small a and small b, if we substitute in the exponential equation of type 1, y is equals to a power bx, then we are going to get a estimated y, which is the best fit for the given problem. So this is how we are going to convert non-linear equation into linear equation. Then we are going to apply Lagrange's principle of least square, and then we do the small conversion whatever required, then we get the best fit. This is exponential curve of type 1. Type 2 also we will see how it will be. Fitting of exponential of type y is equals to ab power x, which is non-linear. Now, the non-linear equation, we have to make it linear. So, taking log on both sides, of equation 1, we get, what do we get? Log y is equals to log of ab power x. So this implies log y is equals to log a plus x log b. Put log y is equals to u, log a is equals to capital A, and log b is equals to capital B. Now the equation will become, log y means u is equal to a plus bx. Now this is a linear equation. Y is equals to a plus bx form में is a linear equation in terms of u and x. So applying Lagrange's principle of least square to this linear equation, which is of the form a straight line. We know the linear equations, that is, what are those linear equations? summation ui is equal to na plus b summation xi, and summation ui xi is equal to a summation xi plus b summation xi square. These two equations, if the given equation is a linear equation and it is in the form of straight line, we know by applying Lagrange's principle of least squares, we can find out two normal equations in terms of u and x, and solving these two normal equations, we are going to get the values of a and b. But our a is equal to, we have taken capital A to be log of small a, implies small a would be equal to anti-log of capital A, and what is b? B is b equals to log b, implies b would be equal to anti-log of capital B. So we got the values of a and b, substitute them in the equation 1, and we are going to get a best estimate for the given equation. So first our task would be, if a non-linear equation is given, we have to convert the non-linear equation into linear equation. So the best part, what I have done to the non-linear equation, I have multiplied both sides with log. So after multiplying with log and simplifying it, I got a linear equation of u is equals to a plus bx. U equals to a plus bx is nothing but a linear equation, and it is straight line. So we have seen, by applying principle of least squares given by the Lagrange, the straight line will give you two normal equations. Those two normal equations should be in terms of u and x. We have written in terms of u and x, and there are two constants a and b and two equations. So we solved these simultaneous equations. We got capital A, capital B values. But we have taken capital A to be log A, which is nothing but small a equals to anti-log of capital A, and small b is equals to anti-log of capital B. Now after getting small a and small b, you substitute in the exponential form y is equals to ab power x, which is your equation 1. After substituting it, you will get the best estimate or a best fit for the given data. Now we have seen y is equals to ab power bx and y is equals to ae power bx. These two equations, we call it as exponential equations. If exponential equation is given which are of form non-linear, we convert them into linear equations by multiplying both sides with a log and make them into a linear equation of the form straight line. Y is equals to a plus bx. But in terms of u's, b's or ux, whatever it is, so the terms will change here. Therefore, the normal equations also will change into those terms, and solving it, we get the problem. Now we will solve power curve. What is a power curve? The power curve of the form y is equal to ax power b. It is in a linear form. It is a non-linear. So it is a non-linear curve. What do we do? We take log on both sides. Log y equals to log ax power b. So log y equals to log a plus b log x. So put log y equals to u, log x is equal to v, and log of a is equal to capital A. This equation will reduce to u is equal to a plus v. Now, we have started with the non-linear curve. Y is equal to ax power b. So it is non-linear. We have taken log on both sides. Log y is equal to log of ax power b. So log y is equal to log of a plus b log x, and log y we call it as u, and log a as capital A, and log x as capital B. Now this is linear equation in terms of u and v. So your x's and y's have changed to u and v. Therefore the normal equations would be what? Yes, the normal equations would be, by applying Lagrange's principle of least square to this equation of straight line in terms of u and v, we are going to get our normal equations to be summation over I, ui is equals to na plus b summation over I vi. And then second one would be ui vi equals to a summation vi plus b summation over I vi square. So these are the two normal equations. This is 1 and this is 2 and this is 3. Now solving these two equations with two unknowns a and b, we are going to get the values a and b. Now, what is A? A is log A equals to capital A, implies small a is equal to anti-log of capital A. So you are going to get A value, you have a B value, substitute in this equation, you are going to get a best fit. So we have seen in the previous class, we have seen two linear equations to be two linear equations, that is a straight line and second degree parabola. Now for the two linear equations, we have applied Lagrange's principle of least square and solved the two normal equations we got. With the two normal equations, we have solved and got the constants a and b and substituted in their original equation, that is the best estimated equation for the given data. Later part, we have seen if the equation is not linear, what we have to do. So we have taken exponential equations. Those exponential equations, we have converted them into, which are non-linear, we have converted them into linear equation by taking log on both sides and converting them into terms, other terms as u's, a's, b's, whatever it is. So after converting them, we made them a straight line and used the normal equations, applied the principle of least squares and got the normal equations, and solving those two normal equations to get the two unknowns and substituted in the original nonlinear equations, and we got the best fit there. So the same way we have done it for the power curve also. So altogether in curve fitting, we have 5 curves, 2 linear and 3 non-linear. 3 non-linear also we have to convert them into linear, and then we have to apply the principle of least squares, and then we have to solve the equation. This part we have seen. Now we will see how to solve the practical problem. I'll give you a practical problem and give you an idea how to solve it. You try at home. Okay? Let us start. Fit a straight line to the following data. Fit a straight line to the following data. X values 1, 2, 3, 4, 5, 6, 7, 8, and Y values 5, 8, 11, 14, 17, 20, 23, and 8. Now straight line. What is a straight line? Y is equal to a plus bx. This is a linear equation. To the linear equation, if we apply principle of least squares, we got the normal equation. What are the normal equations? Summation over I going from 1 to n, yi equals to na plus b summation xi. This is 2. And second one, I equals to 1 to n, xi yi equals to a summation over I going from 1 to n xi plus b summation over I going from 1 to n xi square. This is equation number 3. Now, this is equation of straight line. Y is equals to a plus bx. And to solve this, to get a and b, we have normal equations by applying principle of least squares. Now, Solving these two simultaneous equations, we are going to get the constant values A and B. Now, summation y. The y values are given. So, summation y, if you do it here, you are going to get summation y. And summation x. Here, if you add up all the x values, you are going to get the summation x value. If you add up all the values, you get summation y value. And you want this xi, you have xi. So now find out x square. You get summation x square values. And you multiply x into y. You get summation over xy. Now x square means what? 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, you add up, and x into y is 5 ones are 5, 2 8s are 16, 33, 16, 35, 3 carry, 85, and 120, 21, 2 carry, 14, 48, 4 carry. So you add up, you get this total, you add up this total, you get two equations. Solve those two equations, you get the values A and B. Substitute in this, that would be the best fit of the equation. So you complete the problem. I have given you an idea, fair idea how to do this problem. You finish it off and you will understand what we have done in the today's class. If you have any doubts, please do contact me. Thank you.